Hi, everyone. Welcome. I'm very excited to kick off this session today, where we'll talk about how to build a reliable agent from prototype to production. My name is Alibek. I'm an engineering manager at Booking.com, leading the AI platform team. I'll be sharing this stage with amazing Googlers and my colleague, Maria. They'll introduce themselves later. So, we've been partnering with Google for many years, and this isn't just a one-off project. It's a battle-tested partnership that is built on deep trust and technology that actually delivers. And beyond our performance marketing partnership with Google, we're also harnessing the power of Gemini and Vertex AI to build agentic use cases that unlock smarter and more automated customer experiences. But let me first give you a little bit more introduction about our company first. So this is our mission. We want to make it easier for everyone to experience the world. And this is something that we ourselves truly believe in. It is vital because connecting people with destinations is something that fosters this cultural understanding and personal growth, because we rediscover ourselves, what we like, what we love, what we don't know. And in fact, many of you, if not all, traveled across countries and maybe even continents to experience this very conference in person, embodying that core mission. Can I have a quick show of hands? How many of you today traveled internationally? Wow, that's almost the whole room. And how many of you have used Booking.com app to plan your trip? That's exciting. I love to see so many hands. For those of you who did not raise hands, but maybe for the rest as well, I wanted to give you a sense of how massive our engine is. So let me dive into some of the stats about our platform. So we are not just a booking site. It's a massive online travel platform. Since 2010, we've facilitated over 6.8 billion guest arrivals in different accommodations. We are present globally, so it's a truly international company. We cover 175,000 destinations worldwide. And we have offices across 140 offices across 70 countries, with 7,000 employees in our headquarters in Amsterdam, Netherlands. But the real story here is that we are a multi-vertical company. We've evolved beyond hotels, accommodation, transport, attractions. We are fully integrated, multi-vertical ecosystem. But now let's talk about AI. So Booking.com is not new to AI. We've been running predictive machine learning models for more than 10 years already. Today, we run hundreds of models in production that generate massive traffic of around 500,000 requests per second with roughly 50 milliseconds at P999. But today, we want to focus specifically on the Gen AI. So let me give you a glimpse of our Gen AI ecosystem. And to understand where we're going, let's have a look how our ecosystem matured. So first, we started experimenting in 2023, since the ChatGPT moment. You can see the phase 0. We had a very simple wrapper kind of application. This was our foot in the door in the industry. And by early 2024, we've revamped our core stack and began integrating our in-house models and evolving into a multi-provider environment. But the real shift happened when we moved to a single gateway where our internal users can access any model. And not only that, but also with a critical addition of built-in governance and usage monitoring. And today, we have arrived at comprehensive AI ecosystem. You can see We have a lot of capabilities listed here. I'm not going to dive into each of them. But we're not just accessing models anywhere. We're managing the entire life cycle. From advanced evaluations, safety guardrails, and production-ready agentic capabilities, we now have integrated solution that allows us scale multiple use cases very quickly. And with that, I wanted to hand over to my colleague Maria to dive deeper into particular use cases.
Hi, everyone. I'm Maria. I'm a software engineer, also in the AI platform at Booking.com. And I'll build on what Alibek just shared by showing you a few use cases with Gemini models. So the first I want to focus on is called Know Before You Go. It's actually our first customer-facing agentic solution built as a proof of concept together with the folks at Google. As you may know, waiting for your trip can be exciting, but the planning phase, sometimes it's a bit frustrating, it's time-consuming. So with this project, what we really want to do is to bridge the gap between the time of booking and when you actually go on the trip. So for example, you can plan how to get from the airport to your accommodation, or you can create itineraries based on your group, your interest, your constraints. This was achieved by leveraging Google Maps and search grounding under the hood. And it really shows how reasoning and external knowledge come together to basically form a cohesive experience for the traveler. Moving on now to an internal use case. It's called BigBot. It's our internal data registry chatbot. Users can ask, internal users, of course, can ask general questions about the platform. They can search for data assets, which we know is important in such a big company where you have a lot of information. And also, they can create workflows from natural language. The point here is that we're not just leveraging Gemini for our end users, but also using it internally to enhance developer productivity. Now, moving on to partner analytics, this is a host-facing use case. So on the partner platform, the users can go into extract traveler pain points. So it's not just, we don't just leverage LLMs for text generation. We use it for signal extraction. So a partner can go in and double check, basically extract from comments and reviews the common themes. So for example, they can see that a lot of users, let's say, complain about the pool or the breakfast variety. And that way they know what to really focus on and what matters most for their customers. The final use case I want to present is focused on multimodality. I really love this one. It's called Reels to Reality. It takes short-form video inspiration to real itineraries on the Booking.com app. And we know that travel ideas often stem from visual inspiration. It's not just a proper search query, you know exactly what you're going for. So building an itinerary in Booking really helps you plan your trip better, essentially. Gemini is a perfect fit for this because you can pass YouTube URLs directly to the model, and it enhances the context of the query. And it's, I think, a great example of how multimodal AI can be super relevant for travel. So I've shared a few use cases, but of course, these didn't come without their challenges and their learnings. All of these examples show us one important thing. It's not just about choosing the right model. It's about how we serve the LLMs and make them easy to use across our organization. Most of you may already be familiar with on-demand LLM serving, but we found there are multiple options to serve LLMs on Vertex AI. We found out about this because we've gone through a lot of service tiers and a lot of experimentation. Essentially, one size does not fit all when it comes to serving tiers. Initially, we were using just on-demand, so the default Vertex AI serving option. But for Know Before You Go, our first project, we quickly found that it wasn't really fast or scalable enough. So we switched to provision throughput, which is a reserved capacity of tokens per minute. But that also isn't a bulletproof solution, right? So then we started looking into priority processing for multimodal use cases, like, for example, Reels to Reality. The real takeaway has been that we are trying to match the serving strategy with the production need rather than just assume that a default is going to do the trick. And the second learning I want to focus on is about knowledge sharing and visibility. So we are a platform team. That means we don't develop these use cases ourselves. It's usually self-service, or at most, we support. So it means that building the platform is only half the job for us. The other half is helping users understand what's available, when to use which tool, and how to get started in a way that's really accessible and relevant to them. So we tailor a lot of content, always try to keep it up to date, keep coming up with hackathons, provider-specific information, with the goal to really help people move from experimentation to production. So if I had to summarize our journey in one sentence, it would be this. Booking.com has been moving from isolated GenAI experiments to a governed, multi-provider, production-ready AI ecosystem. And Google is a very important part of that journey, especially as we venture further into agentic solutions. Thank you. Now I'll hand over to Manasa and Naz, who will share 4 principles for deploying agents into production on Google Cloud.
Most of us are familiar with building agents. However, as we're building them, some natural questions arise, like how do we ensure the quality of our agents are up to our quality standards? How do I properly govern my tools and agents as I'm building more and more of them? And as I am following this journey with my agents, how do I make sure I keep them secure while they're running in production? Today, we are going to cover 4 main topics in the next 30 minutes to help you understand how you can go about these challenges. First, we'll dive into how do you evaluate your agents before you put them into production, utilizing various techniques. Then we're going to give some tips on how you can move from code to cloud quickly. We'll then continue with how do you have agent identity at deployment time, and how do you keep your agents secure in production. And then we'll finalize with observability and auditability of your agents. As you're running them in production, you might run into issues that you would like to debug, and we'll look into how you can do that effectively. Before I begin, I would like to introduce you to my colleague Manasa Kandula, who's an application modernization specialist. And my name is Bayrak, and I'm an AI specialist, and we're both based in Google Amsterdam. So we are going to be utilizing a sample demo. Coincidentally, this is going to be in travel domain, inspired from my colleagues from Booking. And we'll have 3 main agents in our sample demo. The main one will be the London Travel Concierge. This is the main agent that will interact with our users, who will give travel itinerary recommendations to them. It will speak via A2A with the ticket agent and activities agent. It will have access to weather MCP server, as London's weather is very unpredictable. And it will also have its own London data MCP server, where it's going to have access to proprietary data that resides in Cloud SQL that belongs to our company, so that we can give proper recommendations to our end users. We'll also utilize Agent Engine and Model Armor, and more on that later. So let's go ahead and get started with how we can evaluate agents. Agents are non-deterministic, and this brings some challenges to our evaluation systems. We can mainly split our method of evaluating them into 2 components. First is response evaluation, where we disregard everything that happens within an agent and only take a look at the response. This is very similar to how you do any GenAI model evaluation. And the second is trajectory evaluation. This is unique to agents specifically, where we look into inner workings of an agent and look into which tools did it call, with which parameters and with which agents it collaborated. And then we evaluate our golden goal, which is our evaluation set, against how the agent performed and come up to certain decisions. Now, I imagine all of you are familiar with human evaluation. This is what we did 4 years ago, and any person who used an LLM probably has done this. You take a look at the response, and you decide whether if it was good enough or not. Ideally, if you're doing it professionally, you have certain criteria that you need to evaluate the agent against. Well, this has some obvious drawbacks. It's very subjective, it's time-consuming and expensive. So this brought us to using LLM as judge. This is a commonly used technique that was adopted by the industry, where you have a secondary LLM that evaluates the outputs from the first LLM. And this is something that we mainly use for response evaluation, and it's still pretty valid for evaluating agents. Now, the advantage of using LLM as judge is very scalable, it's efficient and consistent, while it's not perfect, it's not very suitable for complex scenarios. For example, code modernization, it does not work very well with LLM as judge, and it's limited by the LLM's capabilities, of course. We can utilize LLM as judge integrated in automated metrics. So automated metrics, for those of you who are AI practitioners, probably heard about the metrics like RMSE, mean absolute error, and so on. These are the automated metrics designed for agents specifically, some of which we inspire from GenAI evaluation, like hallucination, groundedness, coherence scores, that also utilizes LLM as judge, but you can also have custom automated metrics integrated into your systems. Now, what I'm mainly going to focus on here is the trajectory automated metrics, because that is only viable for agents themselves. Our agents are built on ADK in our demo, so I'm going to walk you through how that works on ADK. So when you want to do a trajectory evaluation, you decide on which metrics that you would like to look into. Let's walk over the first three that is the most commonly used. So you can look into exact match. So you come up with a golden test set on deciding what is the most ideal path my agent should follow. That includes the tools, that includes the tool input parameters and the order of those tools that is supposed to be called for the agent to come up with a certain output. You don't care about the output, but the inner workings need to be perfect. That is the exact match evaluation. So this is specifically relevant, for example, our ticket agent, where it's important that we ticket the customer correctly with the right discount, with the right price, and so on. Then we have in-order match. When we do in-order match, given our agents are not deterministic, it's okay if it calls some other tools. Let's say it decided to call Google search tool when I didn't have that in my golden test set. It increased my latency. However, it did not change the response because it decided it accidentally called it, it was not necessary, and it just moved on. I will still get a correct response in order match. So you can detour, but as long as you get to the right destination, meaning you call the right tools, that's okay. Then we have any order match. This is when you don't really mind. As long as the right tools are being called, the order is not really important for you. Think of us giving recommendations about London. You don't really care with which neighborhood you start as long as you give the correct recommendations to your user. So the advantage of automated metrics is that they're very scalable and they're objective, but no methodology is perfect. It's difficult to measure when it comes to creativity, and it's subject to cheating, especially if you pick the wrong metric for your use case. Now, I'll show you a demo on how it looks in our sample solution. So here, we have the implementation for loading the configuration of our agent on ADK. So the configuration are the automated metrics that we would like to evaluate. Here I have the tool trajectory, the hallucination, the safety, and so on. So that includes the trajectory and the response evaluation. Then I am loading an evaluation data set. I created this using the ADK user interface by having conversations with the agent, and I saved the conversations that I'm happy with as my golden test set. You see it's in a JSON format. Later, we will run a simulation. So we have the input prompts that we prompted our agent to, and the agent has access to golden results. We are going to rerun this agent and see which results it will come up with. And based on those results, we are going to calculate each metric and see how it performs and save the results on BigQuery. So here you see, in one conversation, at every turn, what was the input prompt, what was the expected response, what was the actual response, and then you see all the metric results saved in a granular level, and on the right-hand side, we have the aggregated metrics for the whole conversation. So By looking at that, you can decide whether if your agents are ready to go to production. And once you're there, it is time to get to cloud. And for that, I will hand over to Manasa.
We're going to be switching back and forth often, so you don't need to clap every time, but we appreciate it. So the next step that we cared about is making sure that we were able to increase our developer velocity. By that, I mean we want to specifically make sure our developers are not burdened by all of the bottlenecks that come with taking an agent from prototype to production. I'll explain what that means in a second. So what we've noticed over the last year is with the help of code assistance tools, people are able to build agents relatively quickly and easily in their own local environment. But what we see is that developers generally get slowed down when they have to take this agent that they've been developing locally, running it as a prototype, and then take it into a secure cloud architecture. And that obviously makes sense because, you know, in the advent of the AI era, the rules have changed, the runtimes have changed, architectural principles have changed, so this adds a lot of cognitive complexity. So in order to solve that, we use something called Gemini Cloud Assist. And Gemini Cloud Assist is something you can think of as your AI architect for Google Cloud. So what it does is that it has a really good understanding of the resources and infrastructure that Google Cloud has available, and it can analyze your code base and your intent to be able to translate that into architecture that lands well on Google Cloud. And if you paid attention to the architecture of our London Concierge app, there was a PostgreSQL database with a vector extension over there. So in order to bring that onto Google Cloud, the agent would suggest using Cloud SQL with Postgres. And also, in order to make sure it's secure, it will also likely suggest that you need to make it a private instance. Along with Gemini Cloud Assist, we also have the Application Design Center. And you can think of the Application Design Center as a place where you can store your architectural templates and deploy your architectural templates from there. So you can work with Gemini Cloud Assist and Application Design Center together. And one more advantage of using ADC, I'm going to call it ADC from now on, is that it also gives you out-of-the-box metrics from day one. And we'll take a look at that a little bit down the line. But now, we were talking about developers and bringing their code to cloud. What would such a user journey look like? What would a developer's journey look like? Let's say, for instance, you're using Gemini CLI as your code assistance tool. You would use that to be able to help you generate code. And along with the Gemini Cloud Assist and ADC MCP servers, you can have them analyze your code base, figure out the right architecture for your code base, and also land that architecture on Google Cloud. And in that process, if you have any issues, you can use these two MCP tools to be able to help you troubleshoot. So we'll take a look at a recorded demo to see what that looks like. So the first thing you see is an IDE with our agent's code base. And first, we check to see if our MCP servers are installed, MCP tools are installed. We have the ADC and the Gemini Cloud Assist MCP servers installed. And then we make sure that we have a skill installed that is able to coordinate with these two and make them work to do what you need. Now that we have the prerequisites, we make sure we ask the agent to design a cloud architecture from our code base. So the agent looks through your entire code base, searches through it, tries to understand the components of it, and tries to figure out how they're connected and related to one another. I didn't give it any other instructions except that one sentence. So then, after it has a basic understanding, it calls the Gemini Cloud Assist MCP tool to take this understanding and translate that into an architecture. So what you see now is that after it's translated it, it takes the Terraform version of those templates and downloads that directly onto your code base. And now it also deploys that template onto ADC in the same step. So now we can look at the template in a visual design canvas, and we can also explore the configuration of the different components inside the template and how they're related to one another. Now that we approved this template, I took a look at it, it looked good, I approved it, and now the agents are going to deploy this architecture onto Google Cloud. This is a time-consuming process. It takes about 10, 15 minutes. Obviously, it's fast-forwarded. And it keeps checking to see if there are any issues and checks the deployment status until it's complete. Now that it is deployed, we can actually take a look at that application deployed using the ADC as well. So we can take a look at the deployment logs in Cloud Build. You can see if there's any issues. Everything looks fine. I went through it very, very quickly. And then we can take a look at the outputs of this deployment. And the main thing I'm interested in is the load balancer IP address with which we can take a look at, which we can interact with our travel agent right there. It seems to work, I think. Yeah, it works. So one step further. So what I hope to show you with this demo is that if you have a process where you have an agent or you have an agentic application, you've built it locally, it runs well locally, and if you want to bring it to the cloud, it usually takes a developer days, simply because you have to figure out what the right matching component on Google Cloud is, how do you configure it using security best practices, how do you connect two things together, and this is something that takes many days, and we managed to do this in a matter of about half an hour using these two MCP tools. OK, now we have a bunch of agents and a bunch of MCP servers running in our environment. So how do you make sure you can track what agents and MCP servers you have running? And how do you also make sure that you are reusing tools that you've deployed and not building new ones that are very similar to the ones that you already have? So for this, we have something called the registry. You can think of this registry as a source of truth for your agentic ecosystem. So you can use this as a catalog to store your MCP servers and your agents, and use this as a source of truth within your organization. So one of the advantages it has, one of the main advantages, is that it helps discovery across your organization, so you can see what agents your teams, other teams in your organizations have built, and you can also reuse the same tools and agents and reduce double work in engineering. Alongside Agent Registry, we also have something called the Agent Gateway. While discovery is an important problem to solve, and you can do that with the registry, you also need something like governance. So with teams building lots of agents and tools, you have a proliferation of them, and you want to make sure that not every agent that you have is able to talk to every other agent in your system. So for instance, in our travel app, we would like our travel app to be able to talk to, for example, the ticketing agent, because we wanted to be able to use it to buy tickets for our customers. But we don't want it to talk to our internal HR agent, because that would be really bad. So this is something that typically, if you leave this in the land of the developers, it adds a lot of burden, and it takes a lot of engineering cycles to be able to implement that at the developer level. So we want to pull this up to the platform level, and this is what Agent Gateway does. You can think of it as the governance layer for your agents and MCP tools. And I wish I could talk to you about this for the next hour. I can't. But there's lots of great demos on the floor and lots of talks that will talk about Agent Gateway and Agent Registry. So please be sure to check them out. OK, with that, Naz is going to be talking about safety.
So how do we ensure our agents stay secure while we run them in production? For that, we are going to look into three main components. We are going to get started with agent identity. Then we'll look into the most common threats GenAI applications face while running live and how we can tackle those. And finally, we'll wrap up with talking about observability and auditability when you put your agent to production, and if something goes wrong, how you're going to work backwards from it to fix the issue that you have in place. So let's get started with agent identity. We just released it today, where this is a solution where your agent will have a unique IAM at deployment time. And you don't have to manage it. It will have these privileged access provided by you. The advantage of having such solution, in the case of our demo, say that our concierge agents wants to purchase a ticket. It will do so with its own IAM, so its own authentication. And when something goes wrong and you look back at your logs, you're going to see not just a service that access to that agent, but you'll see exactly which agent, with which version that access was made, and you'll be able to have an irrefutable audit trail to trace back exactly what happened. For example, here on the top, we have our concierge agent that has a regular service role. There, it means you will have to manage the whole life cycle of this role. And in the second and third agents, we defined our agents with agent identity. So at runtime, they were assigned an identity. You don't have to worry about it. If it's not running in deployment, then they disappear, and then as you're running them in production, you'll have access to all of its logs and its behaviors. Moving forward, how do we make sure we prevent bad actors accessing and compromising our agents? There are many reasons why you might want to secure your LLM applications. The common three ones would be not wanting to leak PII information of your customers, protecting your brand reputation via not sharing information about your competitors. You don't want to release biased information and also information that is not relevant to your tone of voice as a company. So for that, we have Model Armor. Model Armor resides between the user and your LLM to prevent all of these from happening. So these are things that you would prompt yourself over a long period of time to prevent from happening, and you would need to do rigorous tests. But if you were to place Model Armor in between, then most of these things are tackled on behalf of you. So let's see how that works in our demo. So here we have the UI of our application. We are greeting our agent, and then we are going to attempt to do data exfiltration. We are trying to retrieve the credit card information from a user. This is detected by our Model Armor, and our agent is not responding to that. Then we'll try to do prompt injection. Again, detected by Model Armor. We'll then have a jailbreak attempt, and you'll see we have many creative attacks that we can have towards our application. Now we are trying to do prompt leakage attack by trying to retrieve the system instruction from our agent. Well, you see the attacker getting frustrated. Violating the safety filter. And then finally, trying a malicious URL filter to see if our agent will actually try to go ahead and retrieve it. Now, to prove you that we did not block every prompt, we are making our agent work as the way it's supposed to. But we're not going to give up. Well, let's see if it can do sensitive data detection. Well, this is something that would have taken us a lot of prompt engineering to get to, while with Model Armor, you can just enable it between your user and your language model to have all of this in place. Given that we talked about identity and agent security at runtime, we'll now move on to talking about how do we debug issues as they arise while running in production. And over back to Manasa.
So I'm going to start with a question. How many of you have had applications run in production? How many of you have production applications? Almost all of you. How many of you have had production applications that have had no issues? Not a single hand up. OK, that proves my point. So the thing is, the crux of the story is, how do you figure out when something goes wrong if you don't have observability? And one of the things that frustrates me is that observability is often referred to as a day two operation. And there's reason behind this. It's mainly because it's not trivial. So as an application developer, in order to be able to get observability signals, you need to instrument your code base. Next, as a platform engineer, in order to be able to get observability signals across your platform, you have to pull these out of your cloud vendor. You have to build beautiful dashboards that integrate with your application signals so that they actually make sense to you and give you information that is valuable. So all of this takes a lot of time and engineering effort. And that's why it's never done on day zero. It's always done as not as an afterthought, but afterwards. But we actually managed to solve this problem for ourselves by doing two things. Firstly, we used ADK with a Google Cloud agentic platform with which we were able to get application observability out of the box with just a click of a single button. And then, if you remember earlier, I talked about Application Design Center, ADC. We used ADC to deploy our entire application. You saw that. And that gave us platform dashboards out of the box as well. And what ADC did on top of that is instead of just giving us dashboards and signals for independent resources across the cloud project, it tied them together as something that belonged to a single application. So we were able to operate the application as a whole instead of signals from the Postgres database, instead of signals from just that Cloud Run instance, et cetera. So with that, we were able to simplify our journey pretty quickly. And alongside with our agent app, we also have the agent app dashboard, which has additional metrics that are useful to anybody who's running AI apps. So you're able to look at things like the token count usage, the latency with respect to certain models, et cetera. And all of these come out of the box. All right, now that we have our dashboards ready, how do we actually diagnose issues once these signals that there's an issue occurs? So we at Google Cloud have been been a big supporter of OpenTelemetry for a very long time. And for those who are not aware of it, OpenTelemetry is a standard that is open and is used by multiple vendors across the globe. And it is there to help you build telemetry pipelines independent of vendors. So it adds a lot of interoperability between different tools, et cetera. And what the OSS community and Google Cloud has done together is extended the OpenTelemetry protocol to also include signals from GenAI sources. So before, when this came up, obviously there was no GenAI and all the telemetry signals were based on normal applications. But of course, if you're building and operating a GenAI app, you need extra signals about the model, et cetera, that OpenTelemetry gives for you now. Let's take a look. Sorry, I'm going to go back. I need to go to a live demo, please. It's worth it, I promise. It just takes a couple of seconds to come up. Do I need to do something here? Okay. I might have to skip this one. If somebody can come and help me for the next demo, I'll come back to this in a second. I was about to show you what one of these traces for GenAI look like. We'll come back to it at the end, so I promise you I'll show you this. So we only do one switch at the end to a live demo. So right now, we have our application instrumented. It runs beautifully. There are no errors that I seem to be picking up, but there's still a very important question to answer. The question here is, how do you know if your agents are actually delivering value to your end customer? Because that is the reason you're building everything, right? So in order to do that, we use something called the BigQuery Analytics plugin, which comes with Application Development Kit, or ADK. So what it does is it takes every single conversation that you have with your user or with the end user, and it takes all of the metadata and the information from it and stores it in a structured database. And for those of you who know what BigQuery is, you know that you can run very powerful analyses on this data to help you deliver business value. Yeah. Can we go back? Thanks. This has a demo too. So. Sorry, what do I have to click? Yeah, great. So first, let's take a look at the trace. So this is a trace for one single turn that the user had with the agent. So what you see over here is you can see every single step and how much time each of these steps took before the end user got the response back. And I also talked about the fact that it has GenAI components in it. So we go to this traditional view of a trace. You see there are several steps over here where you call the LLM. The LLM calls a tool to do a search for data, London activities data, and then gives this answer back to the AI model. And then finally, the user gets the answer. Everything marked with GenAI over here tells you that this has GenAI information in the trace. So if you take a look at this, you see a whole bunch of metadata. You can see that we're using Gemini 2.5 Flash. The temperature that we used was 0.01. The number of tokens I used for this specific turn, which was about 3,658. We need to optimize our agent. But anyway, so you can see all of this in one space. So you can have this for every single conversation. And this is very useful information to have when you're debugging. Now, if we went back to BigQuery, which also captures our users' interaction with our model, what you see over here is data for one specific day. And yeah, so it gives you the timestamp, gives you the event for every single conversation. It gives you the attributes, and if I'm not mistaken, I might have hidden that column, but you also see the content of the conversation. And now with this, I can run very interesting queries. So for instance, I want to know for this particular day, what is the user sentiment? How happy is each of my user with every single conversation? So having taken this data, I run this analysis, and you see this is sorted descending. So that's why you see very happy users in the very top. You see that this person was very happy with what we gave. Yes, day 3 is absolutely perfect. Those are exactly the kind of things I want to do, blah, blah, blah. So that conversation is rated 5 out of 5. But if we go way down, let's go here instead, and I'll sort. This is easier to go. This is exported to Google Sheets. So this is an unhappy user says, this is really not working out. So your tool can't find anything, blah, blah, blah. So that gives you a 1 out of 5. So just by using this data and running a SQL query, I was able to analyze the sentiment of every single user conversation. And that is very useful information for me. And lastly, I can also have a dashboard that I build to see the number of tokens that I've used on a specific day on average. And you see where these tokens are being used. And if I wanted to, and if I could write good SQL queries, I would have drilled down even further and looked at more data about where these tokens are being used up and which type of interaction, et cetera. We can go back to the slides now. So we looked at both of these, and just to end this, we talked about a lot of different steps that we went through in the last 30 minutes about how to get our agents into production. And let's say you do this for 1 agent. It takes a little bit of effort. Let's say you want to do this for 10 agents. Let's say you want to do this for 100 agents. Are you going to be able to scale the steps that we talked about one by one for all your agents in your organization? Scaling manual oversight is really difficult. So in order to solve that problem, we go back to ADC again. Earlier in the demo, we saw that we used ADC to be able to take our code base, analyze it, and generate a custom template for our code directly. But what if we have a platform team in between that has a golden template for all agentic apps in your organization? So they can create an agentic template for any agentic app that is going to be deployed with your organization, which has all the policies, all the guardrails, all the security requirements built in. And then you as a developer just take that template using these MCP tools and customize it to run to your app. Then you make sure that your application, every single application in your organization is compliant. We have 2 minutes left, so I'm going to skip to the very end. Check out ADC. It's a really cool tool, and it really helps build in governance at a platform level. So with this, I hand this back to Naz.
As a recap, we covered 4 main topics. First, we talked about evaluation, how you can do evaluation on agents is through response evaluation or trajectory evaluation. And we covered a few metrics that you could cover when it comes to trajectory automated metrics. Then Manasa talked about how do you get your code to cloud efficiently. She also covered how do you have a proper registry for your tools and agents. Then we talked about having an IAM for your agents specifically at deployment time and looked into common threats that your agents might face and how you can tackle those. She then concluded with how you can do observability and auditability, and also as you're scaling the amount of agents that you're putting into production within your organization, how you can utilize templates to scale more effectively rather than going all of these steps one by one. Given that, I see that we are almost out of time. We will be in the corridor in case any of you would like to ask any questions so that we get to understand your use cases and see how we can help you better. Thanks a lot for listening.